Alright, so today we are working in power functions. Now, what is a power function? A power function is a function that is in the form of y equals a times x to the power of b, where a and b are both non-zero real numbers. So essentially what this is just a number times x to the power of another number, and they're not zero, of course. Now, an example of this would be, I don't know, y equals 17 times x to the power 38, or y equals 4x times 20, or y equals, you can even do this with any real number, so not even just integers, you can use 0.6x to the power of 0.9. Now, what's important about a power function is that we can actually describe this as y being proportional to x, or y varying directly with x. And when we say that, we are bringing emphasis to our a, which is our constant of variation. Alright, that is all we'll need fundamentally. Let's try a little problem with this. So let's say we are on a wind farm here. This is my little wind turbine. I do math. I don't do a lot of art, so please excuse my my quirky little drawing here. This is supposed to be a wind turbine, and let's say we are trying to figure out our power generated by a wind turbine, our little wind turbine here, and it varies directly as the cube of the wind speed v. Now that was a lot of what I just said, but essentially, it didn't even appear on screen. So essentially what this is just we have our power generated, and that is varying directly or proportionate to, so we're going to use a here, our cube of the wind speed. So of course cube is going to be to the power 3, so you have ax to the power 3. And also, let's just say that we knew that when the wind speed is 8 meters per second, so it's flowing at a rate of 8 meters per second, the electric power is equal to 600 kilowatts. Which, I'm a pure mathematician, so I actually don't really know if that's a lot or not. I'm just going to assume it's groundbreaking stuff. Now, we don't actually have a problem to figure out yet, so let's throw that in. Let's figure out. Oh, and this is supposed to be v here, because this is v. So let's just try to figure out what the power would be if v was let's say 10 meters per second. Now, it isn't as simple as just plugging 10 in for v and figuring out p, because we don't know our a yet. So let's use our already known knowledge of 8 meters per second, giving us 600 kilowatts to figure out our a. Because when we know two different variables, we can figure out the third one. So I know I'm just using the same paper just upside down. Anyway, so let's just plug that in. So we have 600 kilowatts equal to a, because we don't know it yet, times 8 to the power 3. And all we got to do now is simplify to isolate for a to figure out our constant proportionality. 8 to the power 3 is going to be 512. And then, because this is multiplying against 512, to isolate a, we got to do the opposite of multiplying by 512, and we got to divide by 512. Now, when we divide both sides by 512, on the right side, we'll just have a, because these guys will cancel out. And on the left side, we'll have, let me put this in our calculator here, we'll have 1.171875. Now, this is not a very pretty decimal, but at least it's terminating, so you don't have to worry about any repeating numbers. If you wanted to rewrite this equation to maybe look more satisfying, you could absolutely keep the fraction to what it is, or maybe you would want to simplify it more. So let's pretend this is already simplified. We can keep this formula to maybe just remind us what we're working with here. But when we work on this, I'm going to keep the decimal. So now that we have our constant proportionality, we can just go ahead and plug this right in. So we have P equals, what is it? 1.171875 times our wind speed, V, which is 10. And that is going to be cubed. So simplifying that down, we have 1.171875 times 10 to the third, which is a quick little trick. If you're multiplying 10, if you're raising 10 to the power, you can just write down 1, and the number zeros would just be how many with the exponent. So 3, 1, 2, 3. And another quick little trick, if you're multiplying a decimal with something like 10 to the power 3, you just got to move the decimal to the right to the number of the positive exponent. So 1, 2, 3, we'll have 1.171875. The decimal is right here, and move to the right 3 times. We have 1, 2, 3. We'll have about exactly actually 1,171.875 kilowatts, or rounded up, you have 1,172 kilowatts. And that's how you use the power function here. And if you are in the class which I am teaching and you haven't done the homework just yet, your homework is to, for one, study for the test, and also to do page 343, numbers 25 to 26.